So in this video, what we're going to be looking at is what we call factorize algebraic expression. And in the previous video, we looked at what an algebraic expression is, and so an algebraic expression should not be anything strange to us, and so we're going to spend some time factorizing algebraic expression. But before we go into that, let us look at what is a factor. Now, a factor is a number that can be evenly divided into a number without leaving any remainder. So let's look at it. So if I have 6, let's go for my marker. If I have 6, and so what are the factors of 6? The factors of 6 is 1, 2, 3, and 6. So these are the factors of 6. So if I want to factorize 6, I could factorize 6 in many ways. I could actually say, okay, I could factorize 6 by saying 2 times 3. So it's just one way of factorizing 6. We could also factorize 6 by saying 1 times 6. So these are basically possible. We could even say 1 times 2 times 3, and so all of these numbers will be multiplied to get back 6. So the thing is that after factorizing a number or a term, you should be able to use back the solution of the factored terms that you have to multiply and give you back the original number. And so let's say I have let's say 10. If I want to factor 10, I would actually have to say 1 times 10 can factor, because 10 can go into 10 one time, 1 can go into 10 times. 2 times 5, 5 can go into 10, 5 times 5 can go into 10, 2 times. And so I would so factors basically, it takes two numbers that can be divided or even more divided into this particular number, and as a product, but take two of them and multiply them and you get back the same number. So you can actually break it down, taking this big number, breaking it down into smaller numbers that you can multiply back and get the same number. So it's actually factorizing the number, finding the factors that can be divided into the numbers without leaving the remainder. So what we're going to look at is the algebraic concept, because these are just constants. So when we're talking about factorizing algebraic expression, we will now include variables, constants, and coefficients, and probably exponents exponents or what we call powers. And so let's look at an example. So if we have 5x plus 20. Now, how could I actually factorize this expression? There is more than one ways. We could actually say, we could say, okay, let us look at all the factors that this term has and this term has. Now, what two term could we get from 5x? Well, 5x is the same thing as 5 times x. So these two terms multiply themselves and it gives you a product of 5 times x. Also with this 20, you could actually break this down in such a way that we find two numbers to factorize it. But let us try to find a number that is probably common to something over here. So that simply means you could actually say 5 times 4. And so when we break it down, like having these two factors of 20, you could actually pull out what is common. So what is common are the 5. So this is common here, this is common here. So we could just pull this 5 out, and what is left is the x plus 4. And so here you go. It brings you back into like a distributive property concept, where I could actually use back the distributive property concept to get back the original where it was coming from. So that's simply that's simply it. And so we could actually look at it another way. We could say, okay, how would we factorize 5x plus 20? We could simply say, we could find what we call the highest common factor of each term. So what is the highest common factor in each term? And so we know what is the word factor already. So what factor of 20 and 5 will consider to be the highest factor that they share? Well, we could actually do one of the demonstrations. So we say, what are the factors of 25? 1 and 5. What are the factors of 20? The factors of 20 are 4, 5, let's say 10, 2, 1, and 20. We don't have any more. But if you look at all the factors that they share 1, 5. And so 5 would be these are all the factors that they share. But which one is considered to be the highest or the higher one? The 5. And so we will actually factor this algebraic expression by 5. And what do we mean by that? We just take the 5 and divide it by each term. So I could divide this by 5, divide this by 5. And so I divide that by 5. But I must show that I'm pulling it out. So the 5 goes here. So 5 into that goes x time, 5 into this goes 4 times. And so we have ended up with the same answer. So there are many ways you could actually look at it. Let's do another example. So if I have 6x minus 3, now we could actually do this the same way. We could do it both ways. We could actually split this up as a product, as two terms being multiplied, to get back 6x. So if we should actually separate these two terms in multiplication, we have 6 times x. And if we should look at this one, we'll actually have 3 times 1. But the thing is that we could actually break this down a little further. We could say 2 times 3 times x minus 3 times 1. And so if we should look, we should actually pull out what is common. So the 3's are common. And so we'll actually have, pull out the 3, we are left with 2x in the bracket minus 1. And so if we were to distribute the 3 to each term by using the distributive property concept, we would actually end up back with the same problem. So your solution can bring you back to the problem. And so that's just one way of working it out. We could actually, but this is really detailed in terms of solving it. So we could just simply do this. We could find the highest common factor of 6 and 3. So the highest common factor for 6 and 3 would be 3. You could pull 3 out, you divide 3 by that, you get 2. Even x, we divide that into that, we get negative 1. So we are actually seeing the same thing. Let's do another one. So say we have if we have 100 minus 40. Right. Now we could actually do this many ways. We could actually do this several ways. We could actually split this up. We could actually break this down as we did the first time. So we could just say, let's say, we could break this down into let's say 20 times, 5 times 20. Minus, we could say 2 times 20. Because aim is always to try to get in both terms you get a common number, which would be the highest common factor in any way, but you just see it in a different light. And so what we will do is we pull out the 20, and what is left after pulling out the 20, because the 20 we have 20 the 20 are common, so pull the 20, leaving us with 5 minus 2 xy. And so if we were to actually multiply the 20 by each term, we'll actually get back 100 minus 40y. And so that's basically a kind of the same factorizing by the highest common factor. And so we'll be looking at another one. So let's look at, let's see, okay, here's one. So we have 4x squared plus 35x. So what are the commons do we have in this expression? Well, we could actually split this up the way that we wanted to. We could actually say, okay, we could have 7 times, well, 2 times 7 times, let's say x times x, because we're actually breaking up the x as well, plus 5 times 7 times x. And so we're actually finding products, factors of the term that actually when we multiply, if you should multiply with everything, we get back the problem. And so that's what we're actually doing, breaking it down and pulling out the numbers that actually, the numbers are the terms that work as a product, can actually work as a product of the number to get it up. So what we could do, we could pull out what the common things. So what we see the 7 is common and x's are common. So we pull out 7x, leaving us with 2x plus 5. And if we were to multiply this, if we were to distribute this 7x by each term, we will end up with the same. We will end up with the same thing. We will end up with the same thing. Fly high, fly low. So 7x times 2x gives us 14x squared. 7x times 5 gives us 35x. And so, but as I said, we could have done this another way. We could have actually done this another way. We could say, what is the highest common factor of 4x squared and 35x? Well, we know that they share 7 as highest common factor and also the x's. So we just pull out 7x, we divide that into that, it gives us 2x, we divide that into that, it gives us 5. And so let's look at another example. Now, a squared minus ab. So we could actually break this down. We could say a times a. So this is actually a times a. These are the two terms that multiply as a product to give you this term. And so we could actually break this down. We could say a times b. That gives us ab or negative ab. So we could actually pull out what is common. The a's are common. So we pull the a's out and we are left with 1a minus b. And nothing in the bracket can be worked out. So we'll just leave it just like that. If we were to actually go back to the problem, we could say a times a give us a squared, a times negative b give us negative b. And another one, we could actually look at this one. We could just break this down the same. But we always try to break this down in such a way that we can think of a number that both of them would share as a factor. And that would be our highest common factor. So we could say, how could I rewrite 6? How could I rewrite 12ab? So 12a could represent as 6 times 2 times a times b. Plus, let's get a different color. Plus, it says 6 times 3 times, so it's supposed to be a. I don't see, it's supposed to be a. Well, C, I'm correct. It's C, it's okay. Let's see. What is it? Times B. Oops. I have two multiplication signs. B times X. So we search on what are common. You see this, well, not really common, but the term that is considered to be the highest common term or factor. So we say this 6 is a factor of 12, 6 is also a factor of 18. So as you look at it, 6 is the highest common factor on both sides when you compare. And so what else we have as factors? We have the B as factors. So we pull out 6b. We don't have it anymore. And what we do is multiply the 2a plus 3c. And so if we were to multiply, if we were to do the distributive property, because remember that the distributive property is at the reverse of factorization, or the factorization is the reverse of distributive property. because if you would factorize an expression, you can, if you should distribute it, if you factorize an expression, it basically can bring you back to the distributive form, where you can actually have a scale outside and you're multiplying it by everything inside of the bracket that was just factorized. And so you realize if you go back way, or if you go forward or back way, you're actually bouncing up on factorization and the distributive property. And so if we should actually distribute these, we'd have 6b times 2a, that would give us back to 12ab. And if we factor this out, we'd have 18 BC. And so there we go. So look at this one. Let's pull out what we can pull out. As I said, there are more than one ways. So we could actually break this down very detailed, like we say 11 times 1 times g times h times h. We say we could write this as 2 times 11 times h times h. That's basically factorizing each term, breaking it apart to see what are the factors that actually are actually comprising. What are the factors that are comprising of these terms? And when you look at it, this is the broken down idea. And so what we could do is to circle what are the common things in each expression, or each term, or each side of the expression. So 11 and 11, we have h and we have h. We don't have anything else. We don't have any more things here. We don't have any more. We don't have any more. No more common things. So we just pull out what is common. So we pull out 11h, and we are left with 1 times g, which is just g to the second power, plus 2 times h, which is 2h. So if we were to actually use back the what is outside to multiply with what is inside, we'll get back 11h times g to the second power gives us back that. And if we were to do the same thing, we'll just say 2 times 22 gives us 2 times 2 gives us 22, and 2 and 11 and what's that? 22. So we actually multiply the number with the numbers and the variables with the variables. So 11 times 2 give us 22, and h times h. I remember when we were doing indices, if we're multiplying two common bases, we take back one of the bases and we just add the exponent, so that will give us back a square, and so it gives us back that. Let's look at another example. Now, if you should actually look at this question, explain why, well, it shouldn't be a question, it's more of it's a statement. Explain why this fact, 7x minus 3 cannot be factorized. Well, when you look at, if we can do this in many ways, we could actually, more than one way, not say many, but more than one ways. We could actually look at the expression to see what is common in this expression. What is common? So if we should break this down, what we have 7 times x, and we could say minus 3 times 1. We have nothing that is common. Nothing that is common. Unless we have a 1, because if we should multiply these two terms by 1, we get by the same negative 7x. And so if we have 1 as the highest common factor for an expression, you will end up with the same. You'll be getting back the same expression from the original. We could actually try it. Since we have 1 as being the common terms, put it outside, and we say 7 times x gives us back 7x, and we say on this one, what, negative, we have negative 3. And so if we were to just multiply, you say 1 times 7x gives us back 7x. 1 times negative 3 gives us back negative 3. So we never had to do anything. So this cannot be factorized. We don't have because if we should factorize this expression, we should see some changes in terms of what it is being broken down in such a way it's actually simplified, and we did not do that because we get about the same thing. And so it can't be factorized because it doesn't have a common factor, highest common factor that we actually break it down for it to look another way compared to all the other things that we looked at. And so that's just a simple way of looking at it. Let's look at this. If you had 2x, let's say 6x, we say, plus, let's say 4. So this could be factored some more. So let me just put something here. If I say 3x plus 2. Now, if I ask you, if you look at this expression, this is actually factorized. If I ask, what was the expression that was factorized? So this has been factorized, but where was this expression coming from? Where was this factored form coming from? We could actually do the reverse. Actually, we can just multiply this by that. So we say 2 times 3x gives us 6x, and 2 times 4, 2 gives us 4. So it is coming from this. And we could also try to see if this is true. We could actually break this down. We could say, okay, we could say 6 times 2. Well, not 2, I'm sorry. But it's rather 3 times x times 2 plus 2 times, let's say 2. So let's see what we have in common. We have the 2's that are common, nothing else. And so we are left with 3 times x, that's 3x, and just that 2. And so that's where it's coming from. So that's simple factorization. Find the highest common factor for the terms and pull that factor out and just divide that factor, highest common factor, by each term. Or you could just break down the terms in such a way that you can see all the factors that come together in multiplication that give you back that same number that it's coming from. And just circle what is common and pull that outside, and what is left you just multiply and place it inside of a bracket. So I hope this video will actually help you and understand you factorize.